In this video with mathematical modeling minds, I'm going to talk about Pandas library in Python. What is Pandas? Pandas is a fast, powerful, flexible, and easy to use open source data analysis and manipulation tool. It is built on top of the Python programming language. It allows Python to read in datasets from various formats such as CSV files. It can quickly grab statistics from data. Pandas can be installed using pip and conda in the command line using pip install pandas and conda install pandas. To work with Pandas library, you need data. Either you can create your own data or import from files. I am using a file called sales.csv for this demo. I have provided a link to the dataset and to the Python code in the below description. First, I import pandas as PD. Then I read the CSV data file as a pandas data frame using pd.readcsv, and inside the parentheses I use the file name. Remember to save the CSV file where you have the Python script, or else type the path for the file within parentheses. If you want to create a data frame from an Excel file, you can write pd.readexcel and within parentheses the file name. And I save this data frame as df. I print that df and you can see that our data frame has automated index numbering for rows. We have 6 columns named country, item type, unit sold, total revenue, total cost, and total profit. Here is how to weave the top and bottom rows of a pandas data frame. In order to weave top rows, type df.head, open and close parentheses. It will show the first 5 rows of the data frame. To observe the bottom rows, type df.tail, open and close parentheses. You can type an integer within parentheses. If I type 3, it will show only 3 last rows. The same can be done for top rows. Guess you want to grab all the columns in a data frame. Then you can use the attribute columns and it will show all the column names used in this data frame. Same as columns, we can point the indexes or the rows in a data frame with the attribute index. Writing df.info will present you all the information about the data frame, such as how many non-null entries you have, data columns, how many objects you have, and type of objects. Total revenue is an integer type and cost and profit are floating points. While for string type objects, it returns objects as the data type. We can also see how much memory is used inside our computer. df.describe will present a statistical summary of the data frame. The count, mean, standard deviation, quartiles, etc. When working with a dataset, it is a good idea to compute summary statistics. They can tell you more about your dataset. For example, about outliers and the symmetry of your dataset. Pandas library has several aggregate functions that can use to summarize a dataset. And here I have provided a list of them. We can read the values of a column in the pandas data frame by writing the name of the column inside square brackets. I can find statistical values such as minimum, maximum, mean, sum, etc. using min, max, mean, and sum functions. We can use these functions for the entire data frame, which will return a summary of all columns. Here I have used df.sum, which will print the sum of all columns separately. When we are working with large datasets, sometimes we are interested only about smaller subsets. That is why slicing is important in Pandas. So we will see how to select columns in Pandas and how to do slicing operations. As I mentioned before, we can read the values of a column in the Pandas data frame by writing the name of the column inside square brackets. First, let's look at the difference between using single square brackets and double square brackets. Single square brackets return a series of objects, which is called a Pandas series, and double square brackets return a Pandas data frame. And if you want to grab multiple columns of data, you can pass in list of columns. For example, say you want to access the values of country and total profit. Now you can see the country column and the total profit column. So this is a new data frame. Remember that you cannot obtain multiple columns in Pandas series. If we do so, we get an error message. This is one of the most popular errors done by beginners. With the Python series, we can do slicing operations. First, I get the Pandas series for country column, which includes all country types. We can use slicing, specifying the start and end indexes. The end index is not inclusive, and this behavior is similar to a Python list. As you can see, I have specified indexes from 3 to 20, so the result displays from 3 to 19. The pandas attribute .lock will allow you to select columns, indexes, and slice your data. First, type df.lock and within square brackets type colons, which means all rows, and then within square brackets you can specify the column name. .head will print the first 5 rows of the pandas data frame. And if you want to have a pandas series, just remove the square brackets outside the column name. It will return a pandas series. Filtering is also used to get a subset of data from the entire data frame. Before talking about the filtering operation, we will see how we can get details about different columns in the data frame. First, I have printed the 3 first rows of our data frame. Imagine that we want to find what are the unique values in the column item type. Then we can use .unique with open and close parentheses, which will print all the unique values in that column. And to know how many unique values, then use .nUnique with open and close parentheses, which gives the length of unique values. Further, using .value underscore counts returns the number of entities of each unique value. We can use conditional filters in Pandas as same as in NumPy. Look into my NumPy crash course if you haven't. So, this is our entire data frame. Let's imagine that we want to subselect a data frame from this entire data based on a certain condition. For example, I want to find the total profit only from baby food. We can do this manually for small datasets. But here I write the conditional statement where item type is equal to baby food. As a result, I get a set of Boolean values, and I have printed that out here. In this list, the first element is true. That means the first item is a baby food. The rest shows false. So we have a long list of items, so we can't see what is happening in the middle of the dataset. Now I'm going to print out only the rows that are representing baby food items. For doing that, I can pass the set of Boolean values into my data frame. I write the name of my variable set of Boolean values inside square brackets, and it will return only the baby food items. So we have 7 items here. And our goal was to find the total profit only from the baby food. So what I'm going to do here is to define a NumPy array from the baby food sales first. Then I create a subarray from that which includes only the total profit data. Finally, I write a for loop to calculate the sum of profit, and the result is displayed here. And these are other operators which we can use for filtering operations. It is also possible to combine different filters. I have used .lock attribute, and I have used unit solved filter and the AND operator and the item filter, followed by a colon to represent all columns. And these are the logic operators used for combining different filters. When you are working with datasets, you will often run into problems caused by missing values. In Pandas library, missing values are denoted by nan or none. Before graph the data, it is very important to make sure that there are no missing values. If there are, they can cause errors or misinterpretations. Missing values could be included in a dataset because of originally missing them or as a result of data manipulation, for example, a product of data. I took the same dataset we used and created a missing value by purpose. Let's see how we are going to identify this missing value. I'm using df.info. This will point a summary of all non-null values. Here you can see that in every column from 0 to 4, we have 100 non-null values. But in the total profit column, we have only 99 non-null values, which means that there is a none value in that column. How do we find which row is supposed to have this missing value? There are 2 common methods used to indicate where the values in a data frame are missing. They are isNa and isNull. They are exactly the same methods but with different names. So I'm going to use isNa for this task. By typing df within square brackets total profit dot isNa open and close parentheses, you can create a set of Boolean values where false indicates not a null number and true indicates a null value. I'm assigning this filter to a variable called profit missing, which will help me to isolate the missing value. This code here with .lock help me to look at the row which has the missing value. As you see, we are missing a value at index 22. Removal of missing data. This is a very important topic to discuss when you are dealing with datasets that have missing values. Before you graph data, you must remove or fill it with a suitable value. In Pandas, you can remove missing values using dropNar method. You can drop entire rows if they contain any nuns in them. Here, just for presentation purpose, I have sliced the data from index 20 to 25 because we already know we have a nun in index 22. And you cannot see that anymore in the data frame. Anyway, this may not be a good option when having missing data. The other method used to deal with none values is to fill them in. There are a variety of methods available for that. First thing we do is to check where the missing data is located. Here you can see that we are missing a value at index 22. You can fill the none with 0 using fill now. And you can fill it using the method bfill, which will fill it with the value of next index. That means it will replace the missing value with the value at index 23. Or you can fill it using the method ffill, which will fill it with the value of previous index, that is the value at index 21 in the Pandas series. Further, we can use linear interpolation to fill that value, which use previous and next values to estimate the value at the none. And finally, if we know the actual value, we can fill the none with that actual value. Here, the profit is equal to revenue minus cost, and we know that. So I have replaced the none with that real value. By using df.info, you can make sure that all missing values are filled. Now I am going to use both NumPy and Pandas to generate a Pandas data frame. First, I import NumPy and Pandas libraries. Using NumPy, I generate an array of 21 elements and then reshape it to form a 7 by 3 matrix. In my second step, I convert my array into a Pandas data frame. Look that when you convert the array into a data frame, it has automatically generated indexes and column names. It is possible to change the index names and column names. But here I have only changed my column names to X, Y, and Z. And it can be done for the indexes as well. Without following two steps, we can do it at once using this method as well. So this will split these X, Y, Z into 3 columns as names. Before we generated Pandas data frame using NumPy arrays. We can do it in the other way as well. That means it is possible to convert a Pandas data frame into a NumPy array. I have used the data frame we developed and converted that into a NumPy array using two NumPy method, or we can use dot values method. Both methods do the same task. This is important because some libraries do not accept Pandas data frame as input to their methods. So this is a task for you. In this task, we are going to generate two Pandas data frames, df1 and df2. So I have given the answer. In the first data frame, the indexes are dates from 1st January 2021 to 10th January 2021. The columns are numbered from A to E. So our data frame has a dimension of 10 by 5. You should follow the NumPy's random number generator C2101 when creating this array. And in the second data frame, we have indexes from 0 to 10 and columns A, B, C, D. Column A has a constant value of 2. Column B has a constant value, a date, 2021, January 8. The column C is a linearly spaced numbers from 1 to 10. Column E has two categories, X and Y. So I have given the resulting data frames and try to do this task yourself first. For the answer, go to the link given below in the description. Managing columns. Depending on different circumstances, we may have to rename or delete columns in a data frame. Let's see how we can approach that. Renaming. Why we need to rename columns? By just typing df.country, I can access the country column in my data frame. But if I type df.itemtype, I'm supposed to get an error because there is a space in between the column name. Therefore, if I want to access that column, I have to put that in a square brackets with quotations. And my job will be easy if I can access columns directly as I did for country column. What I can do is to rename the columns so there are no spaces in between. My first approach is to use rename method with a dictionary substitution. Here I define a dictionary with old column names and new column names with dot rename method. After renaming, I have assigned them to the original data frame. And you can see that we have new column names. My second approach is list replacement. However, with this method, I need to list rest of the columns other than the renaming columns and assign it back to the df.columns attribute. I changed the country column to country name, which you can see it in this printed data frame. So this is the dictionary method and this is the list replacement method. The columns of a data frame can be deleted using .drop method, which allows you to drop multiple columns at once. Further, we can use del method to delete a column in a data frame. Export Pandas data frame. We can export Pandas data frame into CSV and Excel files. This will be important when you want to share your data frame with someone. Here I have specified the path inside the quotations, and index equals false means we don't want to include indexes when exporting. You can export it to both CSV and Excel files using these methods. So this is the end of this video and thank you for listening, and subscribe to my channel if you like the videos.